In this lesson, we will build an intuitive understanding of the limit definition of the derivative. We'll start with the formal statement, and then turn it into pictures you can see. The derivative f prime of x equals the limit as h approaches 0 of the fraction f of x plus h minus f of x, all over h. It measures the instantaneous rate of change, or the slope of the tangent line, at a single point. Step 1. The average rate of change. Let's draw a curve and 2 points, one at x and one at x plus h. The fraction f of x plus h minus f of x, divided by h, is the slope of the secant line through those 2 points. The rise is f of x plus h minus f of x. The run is h, so the average rate of change is rise over run. Step 2. Take the limit to get the instantaneous rate of change. We now let h approach 0. As h gets smaller, the second point slides toward the first, and the secant line rotates into the tangent line. In the limit, the secant becomes the tangent line at x, giving the instant slope. Step 3. The result and meaning. The derivative f prime of x is equal to the limit as h approaches 0 of the difference quotient. It equals the slope of the tangent line at x, and it represents the instantaneous rate of change of f at x. Thank you for watching. Tap like, share, and comment, then follow and subscribe for more quick problem-solving tips. Let's make math simple, one video at a time, only on muyversemaths.